Truthfully, I like this problem so much I'd definitely put it on the test. Consider the graph of f of x is equal to ax squared plus bx plus c, like the most general quadratic there is. And I want to know, is a positive or negative? Well, a can be any number we want, but because of the way that the parabola is laid out on the axes, it really is limited to either being positive or negative. So we have to think about, what does this a here, this leading coefficient, tell us? And the thing it's always told us is whether the parabola opens up or down. Since this parabola opens up, a has to be positive. Then I ask about c. Is c positive or negative? Well, what part of the graph does c represent? And that is the y-intercept. Since the y-intercept is negative, that means that c is negative. I am definitely going to ask you what the name of this shape is. I mean, we've been spending this half of the chapter graphing quadratics. Every quadratic has this distinctive U shape that has a special name. It's called parabola. So definitely know that one, and know how to spell it too. Now this is the real reason why I like this question so much. I've identified a bunch of points on there, and I just need to know if you can recognize the names of those types of points. So which point is the origin? Well, whenever we come to the coordinate system, the origin is the point 0, 0. So O is the origin. Where's the vertex? That's the point where the graph turns around down here at E. The x-intercept, well, that's where it crosses the x-axis, and it actually happens in two places, F and also at G. The y-intercept is where the graph crosses the y-axis at H. Now you think we've hit every point already, so we should be done. Well, not necessarily, because also the solution to when f of x is equal to 0, right? When ax squared plus bx plus c is equal to 0. Well, what do we make equal to 0? Y. If y is 0, then what we're finding are the x-intercepts. So again, F and G. Where does this graph attain a maximum? That doesn't really happen. This graph goes up forever, so there is none. But it does have a minimum. It does bottom out down here at the vertex. So the minimum happens at E. And which point has an x-coordinate of negative b over 2a? Well, anytime you see negative b over 2a, you should be thinking about the x-coordinate of the vertex. So again, that happens at E.